Hi everyone, welcome to this course. As you know, this course is on biomedical ultrasound, fundamentals of imaging and micro machine transducers. This course will be taught to you by three instructors, Professor Himanshu Shekhar and Professor Carla Makado Shekhar from IIT Gandhinagar, and myself Hardik Jitendra Pandya. I am an associate professor in the Department of Electronic Systems Engineering at Indian Institute of Science, Bangalore. So, what this course content is all about, let us go a little bit in detail and then we will see that what you will be learning at the end of the course, right. So, the focus of having this particular course was to teach students very important area for research and also area in which you will update your understanding about image processing, signal processing, to an extent fabrication and how the wave propagation occurs, how the acoustic impedance would occur, what are the different kind of attenuation, reflection, intensities. Then you can understand how the scattering, refraction, focusing and speckle activities will occur, or you can also not but and you will also understand what is a piezoelectricity, then understand what are the electrical and mathematical modeling that we can use. We will also be teaching you the matching and backing layers, effect of impedance when we go for ultrasound transducers. You see, generally ultrasound transducers when we see is for what we know is for fetal monitoring, right. There is some ultrasound we put on the on one of the part of the body, let us say our stomach or abdomen, and we see the image it, right. But how this works, right, what are the imaging tools, what is ultrasound transducer consist of, what are the matching layers, what are the backing layers, is there any impedance values, once you get the data how to process the data, how to clear the noise, right. All these things are part of this particular technique. Now when we do that we also look into image modes and image reconstruction. Let us say you have a transmitter, you have a receiver, can you use the array of transducer as a transmitter and receiver both? Can you use one electrode, let us say you have array of 8 by 1 or 1 by 8, right. If you have array of 1 by 8 or 8 by 1, how can you use it, right. That is the question. And how to fabricate this ultrasound transducer? We know that okay, ultrasound transducer works on the piezoelectricity, that means you apply a voltage, there will be change in pressure, apply a pressure, change in voltage, but how does it comes into realization? That means that what are the techniques to fabricate this array of what we call as a ultrasound transducer array. It can be a piezoelectric, micro machine, ultrasound transducer, but to understand piezoelectric transducers or to fabrication of that we have to go through several modules. For example, you will be taught how silicon wafers are, because see even though we learn lot of techniques in terms of circuit design and modeling, right, and lot of simulation tools, until and unless you see things, right, that is kind of a 75% knowledge we acquire. Only when we see things the knowledge would improve better, the understanding will improve better, right. So, how silicon wafer looks like is if we call about 4-inch wafer, suppose I show it to you a 4-inch wafer, can you tell me its p type or n type, can you tell me what is the orientation of the wafer, right. So, that we will learn. Then from foundry to silicon, from sand to silicon, what is the process, right. There is a CC technique, there is a FZ technique, we will look into that. Then how the thermal oxidation work, you have seen MOSFETs, right. In MOSFET what we do, gate channel MOSFET, field oxides, right, masking oxides, how these oxides are grown on silicon wafer, we will look into that. And then for transducer, you know that if you talk about piezoelectric transducer, there is a bottom electrode, top electrode and a piezoelectric material sandwiched between two electrodes. How to deposit this bottom electrode, how to deposit the piezoelectric material, how to deposit top electrode, what are the techniques called, for example what is physical vapor deposition technique, what is chemical vapor deposition technique. Chemical vapor deposition is also called CVD, physical vapor deposition is called PVD. Then we look at the micro machine, for micro machining how to create different kind of diaphragms, are we going for bulk micro machining, are we going for surface micro machining. Then comes etching techniques, are we going for wet etching, are we looking at a dry etching, what exactly which technique, which process has to be used for fabricating this particular transducers. Then we look at very important thing which is called photolithography or UV photolithography. We use ultraviolet light to pattern the material of our interest in a particular design for a particular application. Here particular is the ultrasound, right, because we are looking at how to use this ultrasound for new frontiers like elastography. We look at ultrasound safety, what are the bio effects, we look at the imaging artifacts, we see how can we regenerate the image using these ultrasound transducers. So, all things in a nutshell, we are not only going to learn about fabrication, we are not only going to learn theory about fabrication or process flow, we are also looking at the videos. We have a lab videos for you which are recorded right from thermal evaporation, e-beam evaporation, sputtering, we have lithography demonstration for you, so that you can get a better hold of what you are learning. And then once we understand that thing also, we start with some basics of ultrasound, how the wave propagation occurs, how the acoustic impedance works. We start with that, take the fabrication and go to the imaging modalities, imaging reconstruction of the application, some like high end application what we call, or a new frontiers what we call is in the terms of elastography. So, what we intended, right, or we intend to teach you is many things within that 30 hours time frame, right, so that you can use this understanding, right, for some important applications. Either it goes into research where you talk about healthcare, or you can talk about other applications of ultrasound as well. Ultrasound, what we know is only healthcare, right, but it is not. Ultrasound can be used for several different applications, and you will be learning those things during this course of time. Again, using this NPTEL platform, those who have taken the courses earlier, different courses, they know how to approach a faculty, right, using the forum. If you have any queries, you can always ask the forum, and all of us would be available for answering the queries. I hope that you enjoy the course, learn new things, and learn new things, not only learn new things, but apply in your daily activities, like either you go for your research, daily activities if you are a researcher, okay, or you want to start a new research area, or you want to jump into new research area, or just for upgrading your knowledge, right, either or. This course I very strongly believe, and I am sure that my friends in IIT Gandhinagar, we all very strongly believe that it will be very important course for our undergrad, postgraduate student from engineering, whether mechanical, electronics, electrical, physics, those who are interested not only on understanding how ultrasound works, but also to understand how ultrasound can be fabricated. So, I look forward for you to join the course, learn more things, and I am sure that you will enjoy the course content in next 30 hours of your time, right. And again, if you have any questions, you are free you are free to ask us through the NPTEL platform. So, I will see you in the course. Bye for now.